Hello and good morning, afternoon and evening, everyone. Welcome to today's webinar on the subject of timber and water in the Australian construction industry, today hosted by Tecta. My name is Ben Sharples. I'll be hosting the event today. We have a guest speaker as well. I work for a company called Tecta. Tecta is a moisture detection IoT and solution-based system that is designed to be installed in your buildings to detect moisture and monitor moisture conditions of timber structures. Some of the stats sort of surrounding the industry in terms of construction and general construction and timber as well are quite alarming, and that is the reason that Tecta exists. 74% of damages in construction are caused by moisture alone, which is an alarming stat. And actually, when you talk about construction budgets, 3.31% on average is spent on water damages caused by water ingress. On the Tecta projects that we have live today, we're experiencing at least 2 leaks per project, which are critical, and they're being detected and repaired early on in the process. So the idea of the solution is to detect the moisture before it causes any damage. We alert the users or the stakeholders, and that damage can get repaired quickly and reduce the cost of the repairs by approximately 95% or even more. The aim is not to necessarily prevent, but detect early on, and by doing that, we can access the leaks and the damages at an earlier stage to mitigate the knock-on effects and the large costs that might be involved in future. So if you'd like to know a little bit more about Tecta, please scan the QR code there. You can access some of the case studies, some of the projects that we've been involved in around the world, and please get in touch with us if you want to talk a bit further. But today we're talking about moisture in Australia. I mean, when you think of Australia, you probably imagine sunshine and dry weather, but not exactly the place you'd expect to talk about moisture problems. But when it comes to timber construction particularly, water has been one of the biggest challenges. I'd like to introduce Nick Hewson today as our guest speaker. Nick launched Arboralis in 2023 in response to a growing demand for high-quality structural design and technical support for timber structures and prefabricated buildings. Nick has 20 years of experience across the construction sector, from structural consultancy through materials manufacture to prefabricated buildings and construction, and has been involved in the design and delivery of hundreds of timber buildings across Australia, New Zealand, and his native UK. He's a passionate advocate for sustainability and building better buildings, and works with clients both large and small to further technical understanding of timber and low carbon construction techniques. He's also a co-founder of Timber Dialogue, which is a community looking to bring together industry experts to share their knowledge and experience to help increase the uptake of timber. So Nick's going to be sharing a few experiences from projects across Australia, how they've approached timber in both lightweight housing and larger mass timber buildings, and what happens when rain inevitably hits. He'll look at what's working, what's still being figured out, and some lessons learned along the way, especially around keeping timber dry during the construction and over the longer term as well. So with that, I'd like to welcome Nick to the stage. Nick will talk for approximately 40-ish minutes, and after that we'll have some time for a Q&A session. So please add your questions into the comment section, and we'll try and answer as many of those as we can at the end. But welcome, Nick. I will remove my slides and ready for you to add yours.
Thanks, Ben. Appreciate the introduction and the opportunity to share. It's kind of late here in Australia, but it's always good to share experiences around the world, and I think that's been a really key part of my business for the last couple of years. So get rid of that. Yes, put down there. All right. So I guess I wanted to share some of my experiences, just about a little bit about me first, give you a little bit of context about timber in Australia, how it's used and how it's been used historically and how it's being used going forward. I look particularly at kind of water management in construction and in service, what's happening here, what's going well, what's not going well, and then a few thoughts for the future. I will put this up if anyone's triggered by images of wet timber or rot or mold, and yeah, you might need to look away at certain slides, but like all good stories, we have to go through some adversity until we end up with the positive story at the end. So don't worry, it does end on a positive note, but yeah, we do have to go through some images of wet wood to get there. It's been said, I'm originally from the UK. I moved here nearly 15 years ago, though I still support them in the ashes. I've been a structural engineer for 20 years and specialised in timber. I've had a lot of experience across different aspects of timber as well, from manufacture to design and install. And I'll talk a little bit about that in a second. But yeah, the timber kind of got into my blood early days. It's just a sort of snapshot of some of the projects I've been involved in. That one in the top right was the first CLT project I got involved in. I think it was maybe the second CLT building ever built in the UK, which is a small little end of terrace. And that was a project that was a real eye opener for me, and kind of got me into the world of mass timber and CLT in particular. And that's been a core part of my my career ever since, and huge passion for me. So as I said, I've worked across traditional structural engineering. I worked for Australia's first CLT manufacturer in Exlam. So I was there for 5 years as they were setting up in Australia, and got to work on a whole lot of information from them, from testing through project design, and then moved to a kind of prefab construction company as well. So we talk about design for manufacturing assembly, or DFMA, as being this key aspect for timber. But what I've come to appreciate since starting my own business is that I think there's an area that we do forget in there, and that is that sort of ongoing maintenance and monitoring for timber buildings being such a critical aspect that in Australia we haven't kind of got to the stage where we've really realised that yet, and that will kind of become clearer as I sort of work through some of the slides. So I don't know how many people on the call have been to Australia. I know there's a few Australians signed up, but I had, my experience of Australia was, movies like Crocodile Dundee and shows like Neighbours, and I thought it was all, red dirt deserts, blue skies, beautiful sea, sandy beaches, and barbecues and Vegemite. Don't ever try Vegemite; it's gross. But I thought I kind of was coming to this country that was just hot and sunny all the time, and what I actually found was, it is rainy. It is a lot like what many cities around the world. It does have good and bad weather, and and also no one here drinks Foster's, which was a lie as well. But I kind of got to experience this firsthand when I moved here, and I arrived into Melbourne on a kind of winter's night. Went to stay in my apartment that I was going to be staying in. Woke up the next morning, looked out the window, beautiful blue sky. Thought it was going to be a wonderful day for a first day, and went back to sleep for a little bit more of a snooze. And then was woken up an hour later, and it sounded like the roof was going to blow off, and it was raining horizontally. And if anyone knows the band Crowded House, 4 Seasons in a Day it was written about Melbourne. This is a country that has incredible extremes of weather at times, such a big varied climate, and surprising how much it can rain here. And when it rains, it probably rains. Particularly, Sydney, Brisbane had some extraordinary amounts of rain in the last few years. So, a couple of years ago, Sydney had 2.5 meters of rain in a year, which is, for for a Brit that was told to come to Australia for the weather, it's quite confronting when it's 4 or 5 times the annual rainfall of London. So it can be pretty extreme here, and when it rains, it can rain a lot. 100 millimeters of rain in a day is not that unusual, and certainly in some parts of Queensland and New South Wales. So we have a lot of extreme weather here, and that kind of brings some unique challenges. We are particularly during the construction process, and I found a lot of kind of problems with that, particularly through the winter in certain countries, like certain cities like Sydney, can be incredibly challenging. We do have some cyclones and things up north in Brisbane, bringing with that its own unique challenges. If anyone's like me and likes a good horror movie, like Australia's got a really good history. Sorry, Australia's got a really good history of horrors recently, and I'm getting increasingly concerned that timber is going to be one of the next ones. I think we're just starting to see those tip of the iceberg projects now, which are showing some signs of distress, and I will share some of those in a little bit. Sorry, my camera seems to have gone off. I don't know if people can still see me.
We can hear you. Nick, just can't see you. That's all right, but I can hear and see your slides okay.
Okay, we come back.
Yeah, you dropped off a little bit, but I think you're back now. Brilliant.
So a little bit of background about timber in Australia. It's a very common material for timber housing. Up to 90% of the market in some states is timber frame. But outside of that, it's very little market penetration beyond the occasional kind of glulam structure. And then in 2012, that building at the bottom right is the Forte building in Melbourne, and that was built by Lendlease, and that was for a time the tallest mass timber building in the world. That really kind of piqued interest in timber in Australia for commercial buildings, and we started to see a kind of greater uptake of CLT in particular. This was 9 stories of CLT over a concrete podium. This was the sort of first, modern mass timber building in Australia. And then some others that you might have seen: 25 King Street in Brisbane, which was 10 stories. Which is 10 stories. And this again was the largest in the world at the time of construction. This is a hotel building in Melbourne, 10-story CLT hotel, and that was a existing office building that was extended vertically to put an extra levels on top. And I've got a long history with this one. I was involved in this very early days, coming up with the concept and the plans, it's a really exciting use of timber to extend our cities vertically. And this is another one I was involved in Sydney as the structural engineer. 3 towers across a concrete podium again, 6, 7, and 8 stories tall, and this was Australia's largest CLT building by volume at the time of construction. I think it was about 3,000 cubic meters of CLT in here. So Australia was, I think, quite an early adopter by global standards for, still a relatively small country. We picked up CLT and ran with it very quickly, building some of the world's largest buildings very quickly. I think what I've come to kind of realize is that a lot of those early buildings have had some degree of moisture issues, whether that's issues during construction or leaks post occupation. You can very rarely find a building that hasn't been touched by moisture in some way. It has a habit of finding a way in, and it's happening on a lot of buildings, and it's something that I think we're starting to kind of realize that we need to take more care of. So what is being done here when we talk about construction control? Talking about what we do during the building installation, how we're protecting the CLT or the mass timber or the stick frame, how it's protected during those critical months during construction. It's certainly getting more airtime here from builders and installers, but it's still kind of relatively new, and not everyone's doing it. The in-service controls is where I'm kind of really interested and focused at the moment, particularly in my business, because I'm finding that since sort of starting on my own, I get a lot more calls from people that are starting to have problems, and I'm starting to see a kind of trend, particularly with certain areas and certain parts of the building that I'll touch on more in a bit later. And there's limited appetite to address this in the industry at the moment. Like there's not a lot of timber buildings being built, and everyone's kind of nervous about adding more cost or kind of spooking the market. So it's something that's not talked about very often. So starting with construction control, we are still wrestling with what a effective strategy for water control looks like. Most experienced builders and installers will kind of allow for this in their cost plans now, because they've done these and been burned. Most first-time builders, when they get to the end of the project, will say, wish we had done something or thought about water earlier. It was a lot more challenging to deal with, ended up costing us a lot more to remediate and to fix things up after than maybe if we'd protected it better in the first place or treated it properly. And it's certainly a challenge. I think a lot of tenderers will, builders, particularly if they've not done it before, will kind of undercook the prices. They tend to win the project and then get a little bit burnt by it. So it's an area that's being talked about more, but I still think it's a long way away from being kind of the norm to address this. So there's a lot of good intentions, but I'd say a lot of limited knowledge. Here are some pictures from some buildings where using it's actually more of a roofing membrane for floor protection. And one of the things I've sort of found from there, you see that picture in the bottom left, that there was a facade up there, and they thought they could get away without putting a membrane on the floor. And then, over the weekend, it rains, and it rains horizontal, and water will find its way in. And then effectively with the facade, you've actually created a swimming pool. So it's still challenging, understanding where the water is going to go, how it's going to be able to drain, finding the low points in the floor, and actually allowing for water to track to those points and be directed away from the building, I think is really critical. So sometimes the builders will, maybe Australia, but water still flows downhill. So if you have low points in the middle of slabs, in the middle of spans, that's where the water's going to want to pool. It can be hard to then try to move it to the high areas to get rid of it. So use gravity to your advantage, and understand where to drain. Some other issues that I found, poor site control. The sort of photo in the middle there was a building site I went to have a look at, and the floor had been exposed for a long time, and they'd had packets of material and things out on the slab for a long time. And then when you started to move those and shift those around, you found these huge damp patches underneath, which were where the water had just been sat for for months at a time, and it's soaked into the panel. So that site control aspect is really important. The picture on the left is kind of got a good job there, but that water on there, not being swept off, not having a kind of plan for how that's going to be dealt with. Also things like the steel brackets for the props, in the middle of the tapes, creating weak points there. And then the photo on the right is a glulam column that's going to be exposed in the final condition, but because of the way that the building was detailed and there was no tape around the column, all the water had poured down the face of the column for weeks and weeks while the building was open. And then when it came to closing it in and drying it out, it all started cracking and checking, and there's a lot of remediation to happen on there, and that particularly kind of exposed areas need to be dealt with very carefully. So we are getting towards putting membranes on floors more often. There's still a lot of products out there that people are trying out. Every membrane manufacturer will tell you theirs is the best, and we're wrestling with questions like, do we use permeable or non-permeable membranes? Solid or transparent. I particularly like the transparent ones because you can kind of see issues and things underneath before they become a problem. When and where they install, I've seen a number of people trying to install them on site. It's very difficult to roll out and install a membrane on a floor when it's raining and windy. So, it's a lot of challenges like that we're seeing, that we're still trying to find the best way for us to do it here. But it's getting more manageable. There's still a kind of big lack of understanding on who's responsible for these things, like who at the contractor has to manage this stuff. How are they collecting data? I've seen a lot of builders that will give the job to the kind of young cadet on site because they're the cheapest, and they'll buy the cheapest moisture meter they can find, and they'll go around and shove it in a bit of timber once a week, and that data is not used very well, barely recorded, and it's kind of useless. So certainly the more kind of experienced contractors now are starting to put in remote monitoring and use that as a way to collect data, making sure that it's properly calibrated. One bugbear of mine is a lot of engineers will just kind of write on their drawings that the contractor is supposed to keep everything at 14% moisture content, but with no real understanding or consideration of how that happens. So it's all kind of dumped on the builder at the end of the day, and if the moisture's if it's going to rain, the moisture content's going to get more than 14. So how do we manage that, and how do we kind of share some of that responsibility? And I'll share a few thoughts on that a bit later. So I'm going to share some case studies now, mainly when things go wrong. I do this in the spirit of learning and sharing, and I'm not kind of placing blame on anyone in particular. This is the responsibility of a lot of people that in an area that often falls through the cracks. And all of these have been dealt with and are working well now. I'm showing you kind of the worst of some of these just to kind of give some more insight into what happens when it goes wrong, and some of the ways to avoid that. The first one I want to talk about was a school building. It was built from a kind of combination of mass timber and lightweight framing. The main issue on this one was the floor cassettes, which were made from LVL joists with an LVL bottom plate, and that was sat on a load-bearing glulam post and beam structure. So the floor cassette, as you can see there in the top left, was a sort of inverted T-shape with a fiber cement compressed sheet on top. That was all waterproofed and painted and sealed as best they thought. What happened over the weekend was there was a significant rain event, close to 80 millimeters, I think, and there was no one on site to deal with it. And what happened when they came back on after the weekend was they found that the water had found its way into the cassettes, leaked into the floor, and because the floor was made from LVL, and all the timber fibers aligned in the same direction in that particular product, the moisture got into the timber and the whole thing grew. And it was incredible how much and how quickly it grew. I think everyone was quite surprised to come in on the Monday and found that the entire building had pushed out all the walls because the floor cassettes had grown so significantly. And learnings from this has completely changed the way that I sort of detail projects, and making sure that you make the best efforts to keep the water out during construction, but you've always got to be pessimistic and assume that it gets in somewhere, and make sure there's the ability for it to drain. Another one, this one was an unusual kind of hybrid of CLT, concrete, lightweight framing. The floor was a CLT slab with a screed on top, which was not strictly a kind of composite timber concrete floor, but was providing diaphragm action for the building. And then there were some delays during COVID, and the site was shut. And then they came back to cast the concrete. No one really looked at the moisture content in the timber, and just sort of cast the concrete direct on the wet timber. So there were challenges with saw cutting and things in the concrete, and they cut the concrete too deep. So the end result there was a lot of leaks that kind of got in underneath the screed, tracked across the timber, and they ended up having to break out a lot of the floors, completely remediate them, and recast them. There were issues there from the specification. There was no waterproofing on the CLT slab before they put it down. The sequencing meant that the timber was going to be exposed to rain before the concrete was cast. It was almost inevitable. There's several kind of issues across the design and construction that all kind of came together to create a real problem. But some people are doing it well. This was a really good example that I've seen recently. They membraned the panels off site, and then they come in and install the lapping plates and then tape those, and then they use the sealing compound under the screws and tape them, and then they put plywood over the top to then protect all those. So there's certainly projects that are doing a really great job of this, and working hard to protect the materials during construction. It takes a lot of coordination and buy-in from all parties, but definitely we're improving in this area. So some of the things that are, when we're looking at construction control, I always say, if you can look after it during construction, you set it off on a good path. If you can keep it dry when you're bringing the finishes in, then you don't need to worry about putting plasterboard and finishes and casting screeds and things if the timber's kept dry during construction. Like some of the problems occur when you let it get wet, and then construction pressures being what they are, you often find that people will start to want to close things in before things are fully dried out, and then you're trapping moisture, creating problems for the long term. Anything visual needs a lot of extra care, particularly from UV. The sun's pretty strong in Australia and can bleach panels pretty quickly and damage them. So making sure that you've got that figured out, and also just making sure that you have the moisture data, that you understand what's happening to the building, and that you know what to do with it. It's, as I say, it's one thing to send the cadet out and put pins into a panel, but if you're not measuring in the right place and you're not measuring it with the right calibration, then that data is all effectively useless. So make a plan and stick to it. Don't wait till it happens on site. But when I get onto the in-service part, I think this is potentially way more serious. I find that there's a limited ability to see problems until they're too late. They're often hidden behind finishes and can take a long time to come to light. I think there's a real lack of understanding, particularly architects and engineers, and I feel like I can say that as an engineer, on how to deal with durability and what we need to consider. And the timber industry is not super keen to acknowledge the issue, and often puts the blame back on the designers. And then some companies are actively selling unsuitable products, and will point to their terms and conditions and say, "Well, I told you to keep it dry. It's your fault." So I think it's potentially a lot more serious, and potentially that we have a legacy of problems already in Australia that we just haven't found out about. So there's a lot of work to be done in making sure that we kind of put a line in the sand now and detail things better, as well as going back to check those older buildings. So I'm going to talk about the water and service. I guess these are the four main areas where I see the issues. Flooding's fairly unique in some ways in that it's very hard to design for. Certainly, there's a building typology called the Queenslander, because they have a lot of floods in Queensland where the whole building's effectively up on stilts, and that's a great response. But we seem to have forgotten about that and building a lot of buildings on flood-prone areas at the moment, which is causing a number of issues, particularly into northern New South Wales and Queensland. One thing, I apologise for putting up code clauses on the screen. We don't really have a lot of guidance around durability. This is our timber design code, and this is basically the only statement on durability, which effectively says if you keep the timber dry and free of termites, then all good. Don't need to worry about it. But when it comes to waterproofing, what exactly does that mean? Whose responsibility is it to deal with it? And nominally, the engineer will kind of say that the waterproofing is to architect's details. The architect will tell the builder to figure it out, and the builder will pass it on to his waterproofing contractor. So we're several steps removed from the person who probably really cares about it, who's the engineer. It particularly falls into this grey area, and there's not a lot of kind of people really driving the issue, and that's, I think, where we're sort of failing at the moment. Is there's no one clear person responsible for it, so we're missing things. So picking up a bit on one of those, so the internal atmosphere, humidity. I've never been cold indoors like I have in Australia. I'm lucky at the moment that it's sort of springtime here, so my house is actually comfortable, but it's pretty miserable in the winter and pretty miserable in the summer. We don't tend to insulate. A lot of our kind of building stock are kind of timber frame. I'm in a 1940s weatherboard house here that has zero insulation in the walls. It's cold, it's drafty, and that actually helps us in a lot of ways, because when there are leaks and when there are problems, like there's a lot of air in there, things tend to dry out easily. It's quite drafty, even in the best of houses. So we get away with it. But particularly as we get to more and more weather type buildings, mass timber in particular, tend to be a lot more air sealed, so there's less opportunity to dry out, so there's less opportunity to get away with poor kind of building controls. It's amazing how many architects still kind of don't understand that you need to insulate outside a timber building here, and used to kind of concrete buildings where you put put insulation on the inside. That's a poor detail even for concrete. It leads to a lot of condensation and mold. For timber, it can be pretty disastrous. So, there's still a long way we need to go there, and into improving our building standards. But that's certainly happening. And it's a very varied climate. Between Tasmania, Central Australia, and sort of northern Queensland, like we have a huge array of climates, and particularly as you get up into that North Queensland area, building moisture movement tends to do weird things, and you actually kind of want to put layers and things inside out there because of the way that the moisture is going to want to track through the building. So it's a challenging country to build in, and just because something worked in a building in Melbourne doesn't mean it works in Brisbane, and that's something that we're having to learn. But I think leaks, rain, whether that's pipes bursting or leaking, showers not being waterproof properly, rain events, I think this is the single largest risk area for Australia in timber. And the 4 areas that I really focus on in my designs are roofs, bathrooms, balconies, and terraces, and all 4 of those need extra attention. I don't want to bag Australia as being a country that builds badly. I think there are certainly some excellent builders here who do a really good job, but it's definitely something we could do better. There was some statistics I saw on a presentation a little while back that said around 80% of apartments built in the last 20 years have some sort of defect to do with waterproofing. So when we talk about leaks and things, it's an inevitability. It's not a question of if, it's a question of when. Even the best waterproofing contractor, consultant, you can't rely on that for the whole lifetime of the building. The sort of level of fire and acoustic performance that we expect in Australia is quite a lot lower than what you might be used to in Europe. So a lot of our build-ups are quite thin. We don't tend to have multiple layers of screeds and gravels and all sorts of things on top. It's suspended ceiling and some floor finishes in a lot of cases, and that's because of our regulations, and no one kind of wants to put in any more than the regulations say. So it's a challenging area to convince people to put more in. I think we did a little bit of a disservice when we first kind of brought CLT into the country, and I'll put my hand up and say I was one that you talk about it being like precast timber or tilt-up timber. It's just like a precast concrete panel, which we're very familiar with in Australia, but it's made of timber. Isn't it great? And unfortunately, people have kind of treated it and waterproofed it like that. So I think, certainly you need to be asking yourselves, what you need to have a very pessimistic mindset. You need to be asking yourself all the time, what if something fails? What if this goes wrong? What if my first line of defense goes wrong? And this is fairly typical for an Aussie bathroom in a CLT building. You'll have a suspended ceiling below, fire-rated plasterboard and drop ceiling with a screed to falls, and then a membrane which could either be on top of or under the screed, and then some tiles. And that's a detail that we've sort of largely adopted from concrete construction, but they leak. As I said earlier, in something like 80% of buildings, they will leak. And the problem being, particularly with the sort of mass timber floors, is that the water gets in, it will find its way to the timber, and it will take a long time to come out. So you will find that it could be years before you start to notice problems below. It's got to work its way through a full CLT panel, through plasterboard, through a drop ceiling. So there's very little notification from below compared to what you might see with a timber joist system, for example. So you can't kind of rely on finding a water leak from somewhere else. You need to be kind of actively designing against this sort of action, and we'll talk a little bit more about that later. Roofs, I stole these slides from Graham Finch at RDH, and I think I mentioned them later in the presentation as well. Another weak spot. Typically, it's a very large area, so you've got much more opportunities for finding a fault somewhere in the membrane, and they can be pretty fatal. So you need a really kind of robust solution there. And something that Graham had sort of said to me that sort of stuck with me is, if you can put your roof to falls, then you've gone a long way towards helping to mitigate those risks. If that water kind of gets past your first line of defense, it can hit the second line and sort of track to somewhere where you can deal with it. Most roofs in Australia, CLT, aren't built that way. Most of them are built flat. So what do we need to be doing to protect those, to monitor them, to make sure that we're doing the right thing. It's not something that we're really doing in Australia yet, but it's certainly becoming a bigger topic, and the informed clients are looking to incorporate redundancy in their designs for these areas. And then terraces and balconies, and I'll show you some examples of balconies later. But these are possibly the highest risk areas for me, mainly because you get a lot of fixings for balustrades, services, and they're all likely to cause weak spots in your waterproofing system. So you need to be very careful to design for those. Feel comfortable sharing that picture in the bottom left. It's a beautiful house for a good friend of mine in Sydney. Has his own architect in his own house, but he's got a green roof on there, and he took every precaution he could think of under the sun. He had like double, triple layers of protection, and he missed one detail with a balustrade, and it created a weak spot, and the water found its way in and got into the structure. He was lucky that he had a kind of another layer of protection, and that he treated the CLT, and he was able to kind of get in and remediate it. But it just goes to show that you can, the best laid plans of Mice and Men, for example, you have to have that very pessimistic mindset. So in all those areas, in all these high risk areas, I'm always advocating now for double or triple layers of protection, and taking that pessimistic mindset. And the main kind of ones open to us for water are membranes. Treatment is pretty unique in Australia compared to most of Europe, in that a lot of our timber is radiata pine, which is actually very easy, takes up treatment very easy. So you'll find that a lot of timber down here can be treated in pressure treated in the feedstock, so you get a full treatment right the way through the timber. It's not, to me, the treatment is the kind of very, very last line of defense. It's not solving the problem. It's buying you more time to fix it, and gives you a little bit of insurance, but it's not the first line of defense. It's at the bottom of my list of controls. Coatings and things is another one that I think we're struggling with here. We don't find a lot of hard data on what they do, and then they take a kind of a management aspect, and they need to be maintained. And then starting to see increasingly active monitoring and the like being used, particularly in the larger, more commercial structures. So, as with the other case studies, I'm sharing these. I'm not blaming anyone in particular. I'm not here to cast blame at anyone, but some of these are being actively remediated with these, and there's a lot of other buildings out there going perfectly well. So, first one's a CLT apartment building. I was asked out to site to look at some issues of water leaking through some CLT and exposed stairwell. There was a lot of water during construction in this one, and it's left some big gaps in the panel. There's been some leaks through the window, but on the whole, it wasn't that terrible or that deep. A few little areas that needed remediation. When I happened to look through a window into a bedroom and could see some finishes being stripped out, and I could see a kind of tide mark on the wall. So I asked them if I could come back and review it, if they could take off the plasterboard and have a better look at that. And then went back next time and found some significant water issues around this unit and another one. And then when they stripped it all off, they found this sort of a lot of water had tracked up the wall, and in some cases it created some areas of decay. And what had happened on this one, that there behind the shower there had been some poor quality waterproofing. Some water had leaked in through there, but there's also 4 or 5 other places where it could have been coming in as well, from pipes to leaks in the facade to poorly detailed windows. This being social housing, there's a lot of high internal moisture levels and not very much ventilation in some of these. So there was water all over the place, and very challenging to try to work out what had happened. But ultimately, we sort of found that there'd been a water leak behind the shower being the main culprit, and because of the way they'd cast the floor, they cast this screed, and it had created a channel effectively around the building. So as that had been leaking out, bit by bit over a long time, it had tracked all the way around and created some high levels of water that had wicked up the wall and caused some issues. Also found another unit on site, another, again, poorly waterproof bathroom had caused some leaks, tracking up into the wall and then across the floor. These were, quite significant moisture contents in some areas. Thankfully, the decay hasn't been as bad as we thought, but again, this aspect of redundancy, if the waterproofing is not installed correctly, if it's not 100%, then the CLT gets wet and it stays wet. So it's something that we're very, very keen to try to avoid. So this is currently being remediated. We've done a lot of resistance drilling and physical sampling, some compression testing, looking at samples under microscopes. Thankfully, they've dodged a bit of a bullet in that it's not as severe as they first thought, but there's still areas that are going to need to be, chopped out and remediated and repaired. So it's not a minor job. Another one in Sydney, which was a hybrid of CLT floors and lightweight walls, and then some steel framing around the balconies. So what first kind of alerted people to some issues was staining around some of the soffits of the balcony. So they had a double layer of fire-rated plasterboard, which is a bizarre thing to have, but Australia requires its balconies to be 90-minute fire-rated. But what had happened on this one, in the worst case, was in the corner there was a drain pipe which wasn't connected properly at the roof. So the water, rather than going down the pipe, was going down that sort of boxing out around it, and it would hit the slab and it tracked all the way around, creating some significant damage and requiring the balcony to be remediated. And that happened all the way down that particular stack. Some of the interesting things we found here were, the water was sort of tracking around on top of the panel, but then it was getting wicked into the floor. The way that the floor was sort of overlapped to create the set down for the balcony meant that the water would get sucked down the cross grain of the floor. And if I kind of zoom in on that picture I showed before, you'll notice the kind of cross grain is completely gone. Really, it's wet. There's no bond there. It's rotting. But the layers going across actually look fine. So something that is very critical to understand is, you can't you can't see this stuff. Even if you were to go from beneath and put a moisture probe into that bottom lamella of the CLT in that first layer, you might think it was fine. You might have completely missed the fact that the second layers and the fourth layer were gone. So needing understanding kind of these, where the moisture is going to track, how you might monitor it, how you might assess it, where you might put in sensors is critical. And subsequently, they found all the balconies had problems. So membrane failures across nearly the entire stack. So they're currently going through remediating every single balcony, and also looking at issues on the roof. So some of the lessons from that one, designed for high-risk areas for easy repair, removal. Do we even need CLT balconies? Can you put them to falls? And again, allowing for that redundancy. This was one I just thought was fascinating, that I've been supporting the client on, external glulam canopy, and had some embedded steel flitch plates in it to join them together. And this was interesting in that it was the way the water tracked in wasn't due to gravity, but it was getting blown in through wind-driven rain and through capillary action and finding its way in. But yeah, having to design things to drain, you just have to be this conservative, pessimistic person to, think, what if it does get in? What if it gets into this hole, this void? How do we let it drain? How do we get it back out? So that was certainly a key learning there. So what are we doing? It's not as bleak as I might have painted it. I've certainly shown you some of the worst case ones that I know, but there's a lot of good people doing great design, although also some well-intentioned people who haven't been burnt by these issues yet. So, we are working collectively as an industry to both update codes, to develop better details and educate across the whole design, supply and construction industry. And also, we're advocating for taking a much more systematic approach to moisture management. We do it for safety here pretty regularly. It doesn't take a huge leap to do it for water. And again, that RDH guide I find really useful and helpful in that respect, and use that to help inform clients and help kind of step through these areas and work out where and how we're going to mitigate these risks. So what have I learned about timber and water in my career here? It's a really insidious substance. It will find the smallest weak point it can, and it will exploit it. And it's better to be pessimistic and prepared than optimistic and unprepared. It's far more expensive to remediate things than it is to deal with them properly in the first place. That kind of key risk area, particularly in service, always allowing for a minimum 2 levels of protection, whether that's, membranes, 2 membranes, or, that's treatment, or it's membrane and, monitoring. Like you've got to have a backup plan. Make sure you got everyone on board, from the client through the builder, and make water management a key focus of design. Making sure that you look after the building in the long term. Is that it's not just built and done. There's ongoing inspection, there's monitoring, there's maintenance, and if you're missing that aspect of it, then you really are going to have some problems in the long term. And really come to believe that active monitoring is a really solid peace of mind for everyone, for clients and designers alike. But if we can manage the water, if we can deal with this stuff properly and actively, then we'll have a legacy of beautiful, long-lasting buildings for generations to come. And thank you for listening. And we're keen to take some questions. And if anyone wants to get in contact, then please drop us a line.
That's great. Thank you, Nick. Fantastic presentation. Glad you settled the Marmite Vegemite debate there at the beginning as well. I think it's really interesting to see that although there's some big changes in climates throughout the world, you're experiencing quite similar water ingress issues with timber buildings that we get certainly in Europe anyway, that I've been experienced with. But thanks for sharing all that information and some of those case studies that you've been working on. I don't have any questions at the moment. Oh, I've just had a question come in actually from the audience, but I do have a quick question first, if you don't mind.
Yeah.
You mentioned about looking into creating better guidance in terms of Australian codes and documentation and that sort of thing. Do you have like a central hub in Australia or a centre of excellence or an association that you can lean on that has expertise in timber or anything like that? Or do you rely on sort of stakeholders in the industry as a collective to come together?
Yeah, it's particularly challenging here. There's a lot of industry associations. There's in excess of 50, I think, representing different states and different areas, and it's hard to kind of get them all focused. And there's a lot of subgroups. We do have an organisation, Forest and Wood Products Australia, which is the kind of probably the biggest of the peak bodies, and that has a brand called Wood Solutions, which is sort of working hard, and a lot of design guides and things kind of run through them. So yeah, they're probably, I guess, equivalent of Timber Development Association or TRADA or whoever. I've lost track of who they are now, but yeah. So we do have that. It's a little bit under-resourced, and we're probably spread across too many different peak bodies. But yeah, it's happening, but it's probably slower than I would like.
Yeah, sure. Thank you. I've got a question here from Farshid. Nick, do you have any, I can highlight it here actually, do you have any suggestions for sealing and moisture management processes for connections and fasteners that you can share?
Yeah, I think my key one for connections is around avoiding moisture traps. I think that was one of the last sort of examples I showed. You can go a long way towards making sure that your connections are going to perform well if you can be deflecting the water away from them, making sure you don't have slots and pockets where water can collect. A lot of this is not, it's not rocket science detail from the way that we've always built, but it seems when we scale up sometimes to mass timber, we forget some of those good practice details. So I think that's my sort of biggest tip for those is, make sure you deflect the water away as best you can and avoid trapping moisture.
A follow-up question for me on that. In terms of when you come in and look at repairing damage, let's say, do you factor in things like solutions to? Is it a like-for-like repair, or is it like obviously you consider how the damage occurred, but are there things factored in to protect those details in future?
Yeah, certainly there's a lot of remediation. My rule is kind of, whatever you take out, you got to put back in that's, better than the original. That's, the structural aspects of it, but there's certainly the waterproofing one. There's no sense in remediating things if it's going to have the same leaks and problems again. So, really making sure that you have, that sort of double layer of protection, redundancy in there, that you're always making sure that you have, you have that backup plan. So yeah, it's still kind of working on it really. Like, some of the remediation details I'm working on at the moment, and they still seem to be wanting to waterproof it the exact same way they waterproofed it before. And they said, "Oh, we'll just do it properly this time." And it's like, no, because it didn't work last time, and you can't rely on a membrane lasting for the lifetime of the building. So, you need a backup.
Yeah, great. Thank you. Yeah, question here from Jon, and there's another question relating to that as well from Michael, but it's around site cover, and just to make do you have a sort of a cost for site cover? Michael's sort of asking, is there sort of an appetite for adoption of total enclosure as well during the construction process to eliminate those construction phase challenges?
It's interesting that it's being talked about here, but I'm not aware of anyone that's really done it yet. I think it's for mass timber buildings on their own. I think it's probably going to be a challenge, just the kind of cost aspect. I think as we get into more and more prefabrication, though, as we include more finishes, so I do a lot of work with some of the more lightweight timber frame guys here who are building, panelized walls with plasterboard and insulation and finishes in. The order of magnitude of problems if you get those get wet are that much bigger, and so there's certainly some of those who are looking at it, but it's not been done on a project yet. But yeah, certainly being talked about. But it seems to be a kind of cost issue at the moment, or whether it's just builders that are just assume it's going to be costly and kind of park those quickly. But something that we'll be looking at.
Yeah, excellent. Okay, I think we are out of time, but I would just like to thank you again for your time and your presentation today. It's really great to hear the perspective from Australia down there and see some of the projects that you've been working on. Thanks again, and thanks everyone for attending and making another successful webinar through Tecta. But please get in touch with Nick at Arborlis or Tecta to hear more about moisture monitoring solutions. But that's it from us. Thank you very much.
Thank you, everyone.